Great. Thank you so much. Well, let's get into it then. So yeah, this is really a topic that's very close to my heart. I am working as a product manager over on the Power BI team. I've been there since April 2020, and really like a month after I joined, we started on a journey that we now call visual calculations, which was really a journey to make DAX easier. So DAX is the programming language for Power BI, for those that don't know. Um, and I own that language inside of Microsoft in the product team. So that basically means like I'm the product manager for it. So I define what's happening in that language, what the future is, etc. And one of the problems that we of course know with Power BI and DAX in general is that it's really hard to use. Like lots of people are complaining about it. It's in the top 3 or 4 of the feedback loops that we always get is people complaining about the how hard DAX really is. If you ever want to reach out to me, here are my contact vectors. I'm always happy to chat. Like I'm on LinkedIn or social media, or here's my email address if you want to reach out right away. Feel free to do that at any point. Um, so with that, let's see. From those that are already familiar with maybe Power BI and DAX specifically, can I have a show of hands? Who here has ever struggled with DAX? Ever? Yeah, I'll raise my hand as well. Like, you know, if you start writing DAX and you do some very simple things like a sum, that's okay, right? Most people are able to do a sum and understand how that works. Maybe an average, maybe a min or max, it's okay. But already when it comes to, for example, if you're brand new to this, subtracting 2 numbers, loads of people trip up. Like, hey, wait, I have this number here, number A and number B. I just want to subtract the two. Why doesn't DAX allow me to do that? Why do I have in a measure? Why do I have to add a sum or a max on it to like be able to? Why do I have to aggregate these numbers to be able to subtract them? So it's very confusing already from like the get-go, and let alone if you start venturing into calculate or summarize tables or summarize columns or what have you, related table, etc., then it becomes even worse and worse and worse, right? So here's really that's really the proving point that the DAX is considered very hard. And it's really a testament to the quality of the rest of our product that we got this far as a leadership position in our market with our core programming language being considered this hard, right? It's really something to think about and reconsider. So how most of us write DAX today is like this, right? You find something somewhere online, some community, maybe you read the books, you went through the training or whatever, you find it, you copy paste it, or you type it over if it's in an offline scenario, and you press enter and you cross your fingers and maybe invoke some higher DD if that's your thing or not. And that's it. Like that's basically how people write DAX, right? So you read these books. I have them here, of course. You read this one, right? Everybody is probably familiar with this one, right? I also have to show this one because it's a proud Dutch product from 2 Dutch MVPs, which this one is really great because this is the more practical application of the theory that is in here. But you read through this and you go, yeah, I didn't understand it, so I read it again. You read it again. You read it once more. You still don't get it. That is really where most people are, right? And honestly, I am the owner of the language. I don't get most of what's in here. So it's really interesting to see that programming language is so hard. Then we do have quick measures. We do have solutions like that in our product, but really the DAX it generates is so complicated. It's too hard to edit and make any customizations that you might need. And things that are considered very basic by people that are starting out are very hard in DAX. And that boils down to stuff like a running sum. A running sum is not rocket science. You only need an addition to do running sum. You don't need to know about division or multiplication or subtraction even. You can just add numbers and you can do a running sum. A basic step in math is only required to do a running sum. So, and then you walk up to this leading BI tool in the world, Power BI, and you want to do a running sum. And it turns out that's not easy at all. In fact, if you start searching for it, you'll find that there's 21 steps to doing a running sum or a running total. It's all the same in Power BI. 21. Let that sink in for a second. We're not talking rocket science here, as I said, right? Anybody can do this in Excel. Anybody can do this on a piece of paper or in your mind even. 21 steps, really? That is 20 steps too many, if it's up to me. And that's really the problem. So today, let's face it, DAX is just hard. And to be exact, filter context is hard. The measures you define in DAX are scoped to the model. They're independent of each other. So they basically mean they have to deal with the complexity of your data model. Prashant, you have your hand up? Something wrong? Nope. Okay, I'll just keep going. And so typical business type calculations that people think are simple, or management maybe asks of you, or your employer asks of you, are that they think are simple, are very hard to build. And that's because in DAX it's really hard to refer back to what came before. And then of course, as I said, quick measures help, but it's only like treating the symptoms, not really treating the problem on its own, because the DAX it generates is just so complicated and it's hard to comprehend and edit. So this is really the problem, right? Filter context, the fact that a DAX statement is always executed in some context that we don't do a good job of showing you, we don't do a good job of explaining. You have to take the training on day one. That is really a challenge here. So we started thinking about, like, how can we solve this problem? And we said, what if we turn this whole thing upside down? So what if, instead of requiring you to write the measures, the calculations in DAX, all the way in the front, in the beginning of the pipeline, and I'll explain what that pipeline is. What if we required you to write it there, we allowed you to write it way later in the pipeline? So let's talk about that Power BI pipeline for a sec. When I say Power BI pipeline, I mean not like the solutions in Fabric that are called pipelines. I talk about the data loading from the beginning into Power BI until it's visualized on the screen. You're not loading the data just for fun. You're doing this with a reason, trying to visualize data using a chart. So the pipeline for me really means, like, data is loaded from the source and it went maybe through some ETL, Power Query, whatever you, and then the data is landed into the data model of Power BI. You have multiple tables, relationships, you define them. You have this beautiful, hopefully star schema data model. And that's where, at that point, you define your calculations, your calculator columns or your measures. Those are executed inside of the scope of that model. They work on the unaggregated data, and they have to worry about the complexity of the model. They have to know about relationships. They have to be aware of filters coming into the table that the measures are defined on. So any DAX statement is executed within the context of that whole model. After all of that happened, the data is aggregated, filtered, and finally reduced to what a visual can show, right? When I show a bar chart, I only have data points for an aggregated number, a high aggregated number of data points, where that's equal to the number of bars that I want to show. If I want to show 5 bars, the number of data points that I keep around from this millions and millions of rows that might be over here is 5. We're aggregating the data. What if, at that point, when we get to just before we paint the visual onto your screen, we allow you to interject some DAX right there on the aggregated data? Instead of on the low level of data, in the complex, hard to use data model, we allow you to do it right there in the visual, at the last second, just before we start painting the visuals onto your screen. What if we allowed you to do that? And then what if, while doing that, we were able to make the DAX easier, because we can leave all the complexity of filter context and the model behind? We leave it outside the house, we put you inside a little house, and that's the only thing you have to worry about for a second. And then what if, on top of that, we gave you other tricks that would require you to do less typing and maybe do more interfaces with your mouse cursor, like in Excel? What if we allowed you to do all that? And that is really the dream for visual calculations, or visual calcs for short, as we like to call them. What are they? They are DAX calculations on a visual. They are not a new language. It's important to remember. I'm not telling you to stop learning this, right? I'm telling you you don't have to learn this on day one. When you're ready, you can learn this. Whatever you already know about DAX is still valuable in the world of visual calculations, because it's just DAX, but it's DAX in a slightly different context. Haha, poor choice of words there. So they are defined on the visual. They can refer to whatever is on the visual, including other visual calcs. So whatever field or measure is on the visual, you can refer to it. You can on purpose not refer to anything that's not on the visual. That sounds limiting, but that's exactly the point. The fact that we don't allow you to refer back into the model and reach back into the model means you don't have to worry about all the complexity of DAX with all the filter contexts, et cetera, that came in, right? Because you can now safely leave that outside and say, when I'm doing this calculation, all of that aggregation and filter context has already been applied. Power BI has done that anyway to create a visual onto the screen. The only thing I'm doing is while Power BI is doing that, it is showing me what it's working with to paint a visual onto the screen, and it's giving me an option to make some extra calculations right there instead of having to do all that inside of that complex model. So they are executed on the visual. That's on purpose, not in the model. And then they have new tricks because these measures that we talked about before, they're not on the visual. So you have no clue where they're going to be used. A card, a line chart, a map, they have no idea when you write them. These visual calcs are inside of a visual, so they can be visual aware. They know what's happening inside of that visual. And then lawyers require me to say most of the time you don't have to worry about the complexity of filter context. I would say you don't have to worry about the complexity of filter context, but most of the time, just for legal reasons, we put that word right there. So you might be sitting here and going like, okay, that's all great, but what's happening? Like, are you taking away anything? We already had calculated columns. We already had measured. Are you just giving us another tool? How do these three things compare? Well, we're not taking away anything. Measures are still here. They're all great. Calculated columns are great. Well, they're still here. There's some voices in the community about that they're less great. We'll maybe look into that maybe sometime in the future, but not right now. So visual calculations really is like calculated columns and measures coming together. We're taking the best of both into visual calcs. So calculated columns are great because they allow you to just walk up to the table on which you define the calculated columns, and you see the calculated column being executed row by row, and you can easily see how this number that is there, let's say 42, how that number was calculated based on the input of the table. It's very visual. You see it right there. The downside of calculated columns is they're executed on data load. So they slow down your data refresh, as well as they bloat your model because they store the results inside of the model. So if you have multiple calculated columns, your refresh goes slow and your model just bloats. Measures, on the other hand, are not pre-calculated. They are calculated on the fly. The downside of measures is they work in this side of this magical context that is not visualized. You have no idea what the DAX statement does because, well, you can look at the DAX statement, but depending on the context it's being executed in, it will return a very different number, right? It might return all sales for all products in all countries in the world, or just the sales for the red products of size large inside of London, right? The same DAX statement could return both results, depending on the context that is being executed in, and you have no idea what that context is. So then visual calculations actually take this row by row thinking, this very visual thinking of calculated columns, but then calculate on the fly like measures. So it's taking the best of both into one. That's visual calcs. So visual calculations are WYSIWYG. What you see is what you get. Point and click will be provided if you want. You don't have to use point and click. You can still type, but you can also use point and click, or at least you will be able to use point and click. You're just using visible context, which basically means you just see what's in the visual, and that's what you work with. We'll have high-level functions, things that make this DAX way easier. We'll talk about that, and you can refer to visual structure because suddenly we now have a DAX construct that's inside of the visual. Okay, so that's what you need to know about visual calcs. Now, this is the single most important slide. So if you forget everything that I talked about today, this is the one thing that I want you to remember. That is that the mental model of visual calculations is you can represent any visual as a matrix. It could be a very simple matrix with just one cell for a card, or one with just one axis and a couple cells for a bar chart, or multiple axes for an actual matrix, or for a small multiple with multiple axes. If it's a map, you can always represent that same visual as a matrix. And you've seen this already. If you know about Explore, which is the easy way to just quickly create insights that we have in preview as well, you'll see that there is a visual and a matrix, and they're being shown side by side. I think they have the matrix on top of the visual at the bottom, but it doesn't matter. You can change them around, I believe. They are tied together, right? So the matrix represents what the data you're showing in the visual, and vice versa, right? And that's exactly the core idea that we have in Visual Calcs as well. We're showing you the visual you're working on, and then we'll show you the matrix that shows the data that's in the visual, and then you're manipulating that matrix. So you're not working with the visual directly, you're working with the matrix, right? And then, so the visual matrix is the representation of the data in the visual. A visual calculation then adds columns onto the visual matrix, and then you can decide what stuff from the visual matrix to show on the visual. So then anything that's on the visual matrix can be referred to by a visual calc. So I before said anything on the visual can be referred to. That's not entirely true. Anything on the visual matrix can be referred to. You don't have to show everything on the visual. I'll show you that in a second. Now, if you divert your attention to the mockup here on the right, you'll see what I mean, right? You'll see a column chart. It has 3 groups. It happened to be fiscal years. And then 2 bars, 2 series, right? So 2 bars per group. One is sales amount and the other is total product cost. For Power BI, to paint this visual onto the screen, it only needs 3 rows and 3 columns of data. 1 for each group with the name of the group, the label, years, and then 1 for the 2 series, right? So 1 each for the 2 series. So in total, just 3 rows and 3 columns. There might be millions of rows under here in the model, in the unaggregated data. Could be, I don't care. At this point, it's already pre-aggregated. You're not showing millions of data points. We, in our brains, cannot handle that even. So we just show you 6 data points that happen to be in a column chart in 3 groupings and 2 series. So that's all we need. So if you look at the matrix at the bottom, it shows exactly that, 3 rows, 3 columns. And then with those numbers in hand, I can add visual calculations and do stuff with the matrix and extend the visual matrix and work with the numbers that are in there. So with that, let me just go into a demo and you'll see this in action right away. And Oliver, I'll get to your question as well, just right after the demo. But I think Mark already did a great job of answering the question. But I'll have some numbers to share. Okay, so I'm switching over to my desktop. You should still see the captions running, hopefully. And so this is Power BI Desktop. Thank you for confirming, Mark. So Power BI Desktop, nothing special. It's just a public build. I'm not pulling your leg or whatever. You will see this thing called Visual Calculations in our preview menu. So if you go into options, you can enable it already. It's out there since I think late February. We've been working on this for almost 3 years, so it feels like it's only out there for like a couple of weeks, which is kind of true. For 3 years time, and we're not halfway done, right? We're just starting on this preview, but if you want to jump right in or you even want to follow along, you can do that right now using just your normal Power BI desktop or the web, by the way, but I'm showing you that in the desktop. So this is not an internal build, that's also what I'm trying to say. So I'm just going to take something, let's say, just something simple. I'm just going to take sales amount and total product cost, and I'm going to break that down by the fiscal year, maybe sort it by the fiscal year. So I have the fiscal year, ascending, kind of makes a little bit more sense to me. There's nothing special about this visual at all, right? It's a very simple, very basic visual, nothing major happening here. Now, if you look over here in the ribbon, you also actually see there's a new calculation here, a new button. That is next to the quick measures and measures, there's a new calculation button. And that button is only enabled when I have a visual selected. So this is your entry point to Visual Calcs, right? You select the visual, the button shows up. Now, or at least it's enabled. You can click it, and now we are in what we like to call Visual Calculations edit mode. This should feel familiar, because I've just shown you the mock-up on the slide. You see the visual, you see a bar, we'll talk about that, and you'll see the visual matrix. You can do the comparison. You can see that here there is a bar that crosses the 50 million mark 51 million something for sales amount for 2020, you can see that that is this number over here, right? So you can see that this visual matrix shows what I'm showing in the visual. Make sense? Kunal, I'm using the AdventureWorks 2020 DW dataset that's on GitHub. So if you really wanted to follow along, I'll do this again after in the recording. I hope Mark can maybe find that link over on GitHub. It's on our Power BI Desktop Samples repo, and there's an AdventureWorks 2020 dataset.
We'll send that out afterwards. Absolutely.
Yes, thank you. Yeah, I'll find it for you. So with that, you see the visual matrix. You see the visual matrix contains 3 rows and 3 columns. Never mind the total row for a sec. It literally is just what I'm seeing in the visual. Nothing special, right? And now I can use this formula bar, this inviting formula bar here, to start extending my visual matrix. And it's already, adding a placeholder for me. You see there's an empty calculation column in here. It invites me to just start typing. So I can do some stuff with this visual matrix. Now, the first example I'm showing you, I know should have been a measure. So don't go complaining to me afterwards. I know the example I'm gonna show you in a second, it should have been a measure because it's really core to the model. But just as a very simple example, you can do that. So I can do something like profit. And I'm gonna say sales amount minus total product cost. Now, I'm not pressing enter here yet. Just look at this for a second, right? This is simpler than a measure because there's no aggregates. It is like a calculated column, as I explained. What this will do is we'll take row by row the current sales amount for each fiscal year, subtract the total product cost for that single year, right? And then return that result in the cell for that same row. So like that, it's very much like a calculated column, but then execute it on the fly like a measure. Okay, so I can do this. I don't have to type the table name. I don't have to worry about maybe that fiscal year came from a different table as it actually did. I don't have to worry about that. There's no concept of multiple tables here. It's just whatever I happen to have on the visual that I can work with. Will this work? Of course it will. So now we have a profit. Now we have a profit of sales amount minus total product cost. Very simple, very basic stuff as well. Now, let's do something more intelligent. Let's say I wanted to take the profit and calculate the difference in each profit for the year before, right? So for 2019, I want to calculate the difference in that profit versus the year before. For 2020, I want to compare to 2019. And for 2018, because there's no other year here, I want to compare to nothing. What would I do? Well, of course, you can solve this using regular DAX. It's not easy, but you can do it. Or you can just use Visual Calc. So I'll just say versus profit or versus previous profit, whatever, pref profit, whatever name, doesn't matter. Okay, so what do I need? I need profit. Okay, so I can already refer to Visual Calcs, right? And you saw that when I was typing, the only options that are here listed are actually the options that are visible to me and accessible to me. I cannot reach back into the model on purpose, right? So I need profit. Then I want to subtract something. I want to get the previous year's profit. How would I get access to the profit of the previous year? Any guesses? Any suggestions of the name of the function I would use to get to the previous profit?
Anybody else want to put something in the chat? Thanks, Jude.
I see last year, I see previous year. All great ideas. Not generic enough, because what if I changed year to category? I want my DAX statements to still work. -1, all no blank row. Awesome. That is just crazy. Oh, it's a joke. Good. Same period last year. Yes, would work, but not generic enough because that will only work for a year. What if I change to quarter? What if I change to category? I still want this DAX calculation to just do the magic. So the only actual answer here is just the word previous. And then I'll just say previous profit. Look at this. It is almost English. You can walk up to this and say, yes, I get what this does. It takes profit and it finds the previous profit, subtracts the two numbers, return result. Will this work? Well, of course this will work. I designed it, so I know this works. Previous profit. That simple. Very simple DAX statement. Okay, something more intelligent. Let's do that running total or running sum. I want to do a running sum of the profit. Any guesses to the function I would use to call a running sum? Maybe, what do you think? What do I use? Running? Or earlier? Or calculate sum of...
Cumulative.
Cumulative, nice. Calculate sum of filter max equals to lower than max of date stuff? No, it is so easy. You just call it running sum. Running sum, profit, done. Will this work? Of course it will work. Who designed this? I did. You should know how my brain works by now. So let's do something more. We can use this FX button as well to get access to templates. Templates are just an easy way to get started. You don't have to use templates, just a tool for you to discover what you can do. And it hopefully includes a list of things that are like common, right? Common problems. A running sum, a moving average, a percent of parent, a percent of grand total, an average of children, problems that are not easy to solve in DAX. And we just show you how to solve it, right? Versus previous, I've already seen you, versus next, versus first, versus last. Let's do a moving average. I want to see more correct answers now in the chat. You should know how my brain works by now. What would be the function for moving average? It is going to be very simple. People are like, you're just, yeah, exactly. Thank you. Moving average. Of course it is just moving average. Look at that. It is so simple, just a moving average. No, it's not moving because you would have to then also slab on an average. So we just went with moving average because it's the most common one. So, okay, so moving average, profit. And then I need to specify some window size. Window size means how many years do I want to take into my moving average? What's the size of the window that's sliding over this thing? I have limited data here. I only have 3 years, so I'm going to take a window size of 2 to at least show some results. That means for 2018, we're going to return 2018 plus nothing. The average of that is the same number. 2019, we're going to return 2020 plus 2019, take the average. 2020, we're going to take the average of 2019 and 2020. Now we have a moving average. It is so simple. It is almost like English. Now, before I wrap up this demo, I want to call your attention to the visual at the top. That visual is ugly. I'm not the best visualization person anyway, but I can tell this is not a great visual. And why is that? It's because everything that I did showed up on the visual. As I was typing and as I added calculations, you saw the visual being updated. So I really need a way for me to only show the end result onto the visual instead of everything that went into this making of this end result. And the end result that was after is showing the profit comparison year over year, and then the running sum and the moving average. Those are the ones that I want to keep. The rest I don't want to show. Now, you would be tempted maybe to delete stuff from the visual matrix. But you can't, because that would break the rule that I said that a visual matrix, a visual calc can only work with what's on the visual matrix, right? So if I deleted sales amount here, I would break things because profit then suddenly doesn't know what sales amount means. In fact, I can show that by just renaming this to something, say Mark's sales amount, right? It will keep working because profit is just referring to whatever the name of the thing is over here, Mark's sales amount. So it's very clear that I cannot get rid of Mark's sales amount. I cannot get rid of total product cost. In fact, I cannot get rid of profit because everything else is dependent on profit. So what would be the answer? Well, the answer, hopefully not surprising by now, if you go onto here, you'll see a familiar icon just seen from the model view. Right, exactly. Oliver already spotted it. Great job. It is just a hide icon that you can use to hide relation keys, columns that you don't want to show people. You can do exactly the same here. I can just hide everything that I didn't want to hide. I didn't want to show. The visual matrix doesn't change. Everything's still in the visual matrix. I can still see all of it. But now my visual has updated. And it's now way simpler to show exactly what I meant. And I wanted to move the running sum and the moving average to tooltips. And now I have a very simple, beautiful new visual that didn't exist before that I created using very simple line of DAX, in fact, 3 or 4 lines of DAX to get here. Very simple one-line statements of DAX to create something that was horrible, if not impossible, before this feature was out there. So with that, let's go back to the slides, and I have one more slide to show, and then we can take some more questions. So if this floats your boat, and if this is interesting to you, I wanna call your attention to this. If you want to make my day, if you want to post something on social media with just saying mind blown or visual calcs or visual calculations, hashtag Power BI, that would be great. I also have stickers. The future of DAX is visual. If you ever see me anywhere at a conference, ask me for one of those stickers. You'll get one, and if you're lucky, you might also get the very limited edition sticker of the DAX hound, the DAX dog, that is out there. But that's a very limited amount of stickers that are there. But the future of DAX is visual is the sticker that you can absolutely get. So let's see any questions in the chat that I haven't answered yet. I think it started off.
Jay, we've just lost your voice there for a moment.
Oh, sorry.
Oh, you're back.
Can
You're
you
back. Perfect
okay.
Now. Good.
Okay. So the first question I think that came in was from Oliver. Is there a performance hit using visual calcs? And correct me if I'm wrong, Mark, if I skipped over something, but I think that was the first question that was there in the chat.
Yes, it was.
So the reverse is actually true. There will be a performance benefit if you use visual calcs. And we've seen about 500% increase in performance. And the reason is very simple. Imagine one visual that has 4 measures on it. And for Power BI to create this visual and paint that onto your screen, it needs 5 queries to the source. And if that's a direct query source, that is 5 direct query queries, if you're lucky, maybe more. But if it's import, you're doing 5 queries. It doesn't hurt as much because import is close to you, but still, it is 5 queries. Why is it 5? Well, 1 for the visual to retrieve the data that we can actually show, the line or the bar, whatever we're creating. And then 1 for each measure, because I said every measure is being executed independently. So it's being executed on its own every time. So 4 queries for 4 measures. Add the 1 for the visual, you have 5 queries. Now imagine I would rewrite all those measures as visual calcs, all 4. How many queries would I end up with, do you think? The only correct answer is 1. We would retrieve the data for the visual, as we have to, because we have to paint the visual onto the screen, but then all your visual calcs are executed on what we just retrieved, the aggregated data for the visual. So even if you're not using any of these new tricks that I showed you, even if you're not interested in any of that, but if you just rewrote the measures as visual calcs, you would get a performance benefit because we're just killing a whole bunch of queries. Now, that is not entirely true because we're still working through it. So there are situations where this optimization doesn't kick in, but that's the end goal. Cool. So let's see.
The next one is, are normal DAX functions like isBlank also available in visual calculations, from Rahul?
Yeah, Rahul, great question. Yes, the answer is yes. Most DAX will work. There is DAX that won't work, and that's the DAX that relies on the model, right? Stuff that does, for example, related table or use relationship doesn't exist, won't work, because there is no such thing as a related table in here, because there's only one table. For all this DAX model knows, or this DAX execution context knows, there's only one table. Your model is just one table. So related table will not work, but most DAX will work. If is blank, max, average, sum, etc., will all work. So then unknown user is asking about how this works with hierarchies. Great question. I can show that in a second. We have specific functions that allow you to walk up and down the hierarchy and allow you to do interesting things on the multiple levels in the hierarchy as well. So then, is there a management view or otherwise to track down visual calcs? Not right now, but we will have one. The idea is to have 2 things. One is some kind of panel in desktop that allows you to just walk up to a report and go like, what visual calcs are in here, some kind of lineage view or so. The other one is a scanner API. We're updating the scanner API for admins so they can scan out the whole estate they're managing to see which visual calcs are being used. So those are then the answers to that from another unknown user.
That's Jude, actually, Jude Moore.
Oh, okay. Yeah, I couldn't tell from.
I can see that. Thanks, Jude.
I don't see the names. I just see unknown user, which is weird.
All right.
I don't know why. Somebody's asking for the T-shirt. Well, this T-shirt was created by my good friend Mark Lelyveld, the Dutch MVP. So if you go to data-mark.com, you'll find a store. You can get stickers. You can get this shirt. Anything. You can get mugs, whatever you want with this logo and stuff on it. So feel free to go there. Somebody's liking it. Great. Yeah, so let's see. What else?
Chanel asks, is the measure saved so we can refer to different filter context example sales amount by products?
Yeah, so the answer is twofold. A, this is not a measure, and please don't think about them as measures. So this is my pedantic moment for a second. Please think about them as calculations in your brain because they are not measures. Thinking about them as measures will set you up for failure using visual calcs. I've been there 3 years ago. I had to make this mental jump. They are not measures. The things you know about measures are not applicable to visual calcs for the most part. So that's my pedantic mode off for a second. Can you refer to it? No, because it's in the visual calc. It is in the visual. It is called a visual calc. So if you want to refer to it from outside of a visual, you have to bring this thing over to that other visual. For now, we are working through the scenarios of how reuse would work because we recognize that just copy pasting and duplicating logic is not a good reuse story, right? We want to get something else, but we are figuring out what that is. And one of the things that we are, if you look at reuse from a spectrum, measures are pretty high up in reuse. You can use them everywhere in your model. You still cannot reuse them across models, but fine. They score 8 out of 10, let's say. Visual calcs today score 0 out of 10 because you have to deduplicate. You have to duplicate all your logic. We want to get somewhere in the middle to maybe find some way to reuse them, but we're working through that right now as we speak. So you could absolutely migrate to visual calcs and would save performance massively in most cases already, and that will only get better in the future. So I don't know who's asking that. I still only see unknown user, but that's 1036 that was asked.
Okay, and Dan is asking the same question. Dan Boddington has basically asked the same question at 1039.
Okay, yeah.
Maybe last question from Ned Stratton. Yep. You might have to explain yourself, Ned, a bit. What about stuff like all except all selected that allows you to do % of row or column total?
Yeah. Shall I explain what I mean? Basically, so say the matrix, you might not have it by, your one was FY 2018, 19 and 20. You might have it by stock keeping unit or, I don't know, division, or say like animals, cat, dog, monkey, chicken. Yeah. What if I want to see my calc as a percentage of all of them? I would do that in DAX by doing divide sum over all selected. Yes. Calculate all selected sum of that to get all of them. Is it as simple as that on a visual calc?
Yes, you could, but it's even simpler. You can even do simpler things. So I'll switch back to my desktop because there's also a person asking for the hierarchy trick, so we can just answer those two things in one go. So in here, we have this template over here. That is a percentage of parent, percentage of grand total, and average of children. And those three things are very much related. So it allows me to walk up and down the hierarchy, right? So if I have multiple levels, in fact, let me just add another level. I'm going to add the fiscal quarter here. Okay, so now, I have multiple levels in my matrix. I can now use the percent of parent to say, what percentage does each quarter represent for its parent, which in this case is the year for each quarter, right? So I can use the percent of parent. Average of children, for each year, calculate the average of the quarters. This, the profit, for example, in the quarters. Percent of grand total would allow me to refer to any of the totals, like a grand total, of course, the total on the whole matrix. But what if I wanted just a column total? Now, These functions use functions we call, or these templates use functions we call the hierarchical navigation functions. And those are collapse, collapse all, expand, and expand all. Those four. And I'll show you those names again in a second so you don't have to remember them. But basically, collapse allows you to temporarily remove detail. You're collapsing detail away. Collapse all allows you to remove all detail. Expand allows you to do the reverse, temporarily add detail. Or expand all, go to the lowest level of detail, to the highest level of detail, right, with the leave level, right? So if I wanted to do a percentage of, let's say, grand total, I can just do a divide asking for collapse all, right? So I can say divide profit, the current profit, with the same number, but then the collapsed on, let's say, rows. I'll talk about what that axis is in just a second, so bear with me there, right? So this should give me a percentage, and no, it's not going to be nicely formatted because I know formatting is still a limitation. It should really be a percentage, but we'll get there eventually. This now calculates the percentage of the sales for each level in the against the total of that row. Make sense? That is collapse for you. That allows you to walk down. So in this case, walk up the hierarchy, removing detail. Expand allows you to walk down the hierarchy, adding more detail. So that is how you would work with that. Now, let me go to the slides. Now I can show you some more of those functions. So before we get there, what are visual calcs? Just to wrap that up, they're DAX calculations in scope of visual. In support thereof, we have new functions. We have new concepts that you have to be aware of. It's just DAX. Most DAX will work. If you have a calculator column that does a switch through to divide your orders into categories, you can absolutely take that one, put it into a visual calc, and it will just work. Basic arithmetic, as I showed you, will work. Other stuff will work. New visual calculations functions are specific to visual calcs. That will also work. Why is this interesting? Well, if you compare it, visual calcs versus regular DAX, your goal was to implement a running sum calculation, that's some sales amount over a year. Here's the current DAX, a calculator sum or filter, all selected, is on or after over max. Not very easy, not very flexible, and this is the answer on visual calcs, assuming you indeed have a year. On rows, just a running sum. Another example, given a list of states and number of restaurants per state, for each state calculate the difference in number of restaurants in the state versus the state above it. On the left, the original DAX, very hard to do. I wasn't able to write this myself. In fact, I had to call Jeffrey Wang, the inventor of DAX, to get this thing done. It includes a top N1 trick, which is awesome, but also pretty scary. And then on the right, you have the window functions. We released those in December 2022. You might have seen them and went like, why are they doing this? Well, what I was showing you is the Lego pieces that I was using to build the house that is now called visual calcs. Because visual calcs are just shortcuts to these window functions. So I could solve the same problem that's on the left using a window function called offset. It becomes a bit easier. And then, of course, doing this using a visual calc is what I already showed you. A very simple statement with just a previous. So now let's talk about functions for a sec. We have three levels of functions, low, medium, and high. Low is the window functions. You're already familiar with them. You might already know them. You can use them in measured and calc columns. And then medium and high are visual calc specific. Low level, offset, index, window, rank, and row number. I'm not going to talk about all of those. These already work in calculated columns and in measures. You can use them in visual calcs. These are the highest flexibility, but also the hardest to use in comparison. Then the medium and high level functions are just easier to use ways of working with these functions. So these are all the medium level functions that we have. We have a movement functions. Previous, move up or left in a certain direction. Next, move down or to the right in a certain direction. First is jump to the beginning of a direction. Last is move to the end of a direction. So if you have index years, you want to compare something against an index year, then first is your friend. We have an inspection function called is at level. So that allows you to say which subtotal level or grand total level am I on, and to have different logic for each subtotal or grand total. So if you want to do custom totals, this is how you would do it today using some code. If is at level, am I on the year level? Then do this. If I'm not on the year level, I must be on the quarter level, then do this. You have lattice navigation functions or hierarchical functions. expand, expand all, collapse, collapse all. We already talked about them. And then we'll have a selection function with a range that allows you to easily take a slice if you're not comfortable with window. On top of that, we have running sum and moving average. Those I already showed you. So then we have a couple of new concepts in here. Visual matrix, we already talked about that at length. We're going to skip over that. Axis, we're going to spend a little bit of time. Reset as well. Direction is just a combination of axis and reset. And then hidden is the final new concept, which allows you to, we already talked about that, where you allow things to be shown on the visual matrix, but not necessarily on the visual. Now, the thing that makes visual calcs work, and also how you can tell whether or not a function is available in visual calcs, is if it has an axis parameter. That's the secret sauce of what makes visual calcs work. So axis is really, think about axis as how the calculation traverses the visual matrix on which it's being executed. And by default, it is rows. That's why I didn't have to write it for running sum or moving average or previous. It is all by default set to rows, which basically means across the rows. From top to bottom, across the rows. The little arrow icons you also see in the product show you how it's moving. You can also turn it 90 degrees and go columns. If you have columns available on your visual, for example, on a matrix, you can then walk left to right. Simple, right? Now you can combine those two into columns, rows, and rows, columns, which is honestly not very useful, but it's out there. It is usable in some places, it's useful in some places, but it's not very common. But we just put them in there for just completeness sake. Columns, rows is like a typewriter movement. I'm carbonating myself here, but you go left to right, and then you keep snaking down like a typewriter, right? You typed, you finish your sentence, you pressed something, and the thing went to the beginning, one line down, and kept going. Same thing here. You snake down the visual. Rows, columns is 90-degree turn. I think about that as a planter. If you think about planter putting seeds into a field, they go down first, they do something, they go up, they move the little thing, they go down again. They go up, they move the little thing, they go down again. That's rows, columns. Examples. Here's an example of rows. Let's take the first sales amount on rows, which means for each row, retrieve the first sales amount from the first row. We're doing that column by column. So if you look at the color coding, you'll see that the color coding matches. For each year here, we have category here on the rows and fiscal year on the columns. For each year, you'll see the dash box always finding the first value for that year, which happens to be the sales amount for accessories in that same year. Very simple, very easy to understand. Now, with columns, we're turning that 90 degrees. So now we're saying for each column, retrieve the first sales amount from the first column. Okay, so that means we're going to do the color coding, but now across the year. So every color will now return the sales amount for that accessory for the first year, instead of in the other one for that year, the first accessory. Now we're getting the sales amount for the first year in the same accessory. So 90-degree turn, horizontal move. Make sense? Now let's break your brain a little bit. A previous sales amount on rows, columns means for each cell, retrieve the previous sales amount from the row above it or from the last cell on the previous column. So let me get my highlighter here. Let's see, there. Okay, so here, this one is empty. Why? Well, there's no row above it. There's no column to the left of me, so I cannot return anything, right? That's empty regardless if I wrote rows, columns, or rows. Doesn't matter because there's nothing to the left of me. So fine, this one will of course return the value from just before the previous row. This one will return the previous row. This one will return the previous row. Now this one, the yellow one, is the interesting one, because if I just wrote rows, that would have been empty because there's no row above me, right? There's no previous value. But because I wrote rows, columns, if I'm not in the first column, there is indeed a column to the left of me, so I'm allowed to take the last result from the previous column and return that here. So now you can see this snakes like a planter across the visual. 90-degree turn, same thing. We're now taking sales amount of columns, rows. For each cell, retrieve the previous sales amount from the column to the left of it or from the last cell to the previous row. Again, this one is empty. Why? There's no column to the left of me. There's no row above me. There's nothing for me to do. Here, there's a column to the left of me, so I'm returning that result. Here, there's a column to the left of me, so I'm returning this result. This, if I had columns, this would have been empty because there's no column to the left of me, but because I wrote columns rows, I can now get the value from over here, the previous row. And then the yellow one just retrieves the value from the previous column. Arguably, these last two are not very common, but they are available for you to use in case you want them. For example, fiscal years and quarter numbers, 1, 2, 3, 4, makes sense to do this kind of stuff with. Last concept, reset. Reset allows you to define when a calculation restarts. So I can, by default, it's set to none. And that basically means don't restart ever. But reset can also be used to restart on certain levels. So you can say, whenever year changes, I want the calculation to restart. So this allows you to express, for example, a running sum of the sales per month in each year, but not summing across the year, right? So from December to January, when year changed, we're not going to add the numbers from December, the running sum from December, and add the number from January. No, we're starting over, right? So a running sum for all the months in a year, but resetting for every year looks like running sum sales on, let's say, highest parent or reset on year. Very simple expression to express the power of reset. So it allows you to define when you want to restart a calculation while you're doing that. So this is partly still coming soon. We're still working on this, but part of this is already out, like lowest parent and highest parent you can already do. And together, this creates concept of direction. Concept of direction is simply a combination of both. When we say direction, it means access and reset. How are we traversing the visual matrix, and are we resetting the calculation anywhere across the visual matrix while we're traversing? So that's direction. That's all you need to know about that. And that's the last concept. And then we have some more time for some more questions.